Okay, students, this is going to be your teaching video for multiplying and dividing with positive and negative exponents. Before beginning to watch this video, you should have a note page in front of you that the sub gave you, and you are going to take notes on that page, and I will tell you what to write down, and you just need to make sure that you are copying problems and doing them as I ask you to. If I ask you to pause the video and work a problem out, you need to do that, and then when you start it again, I'll go over the problem. All right, so here we go. So we are multiplying and dividing negative exponents. The first thing that we are going to start with is we're just going to review really quick. So if we review very quickly the differences between positive and negative exponents. So if I have 2 to the third and 2 to the negative third, we need to understand that those mean completely different things. 2 to the third is 2 times 2 times 2, which is 8. And then we talked about last week how 2 to the negative third is actually 1 over 2 to the third, which is 1 over 8. So the negative exponent actually makes this a fraction or reciprocal. Now, we're going to add 1 to our step, so we just had 2 to the third, then we talked about 2 to the negative third. Now we're going to talk about what is 1 over 2 to the negative third. Okay, so 2 to the third is 8, 2 to the negative third is 1 over 2 to the third. Now remember last week I told you negative exponents means flip them over, reciprocal. So if it starts as 1 over 2 to the negative third, then that would actually be, we would flip it over and make it 2 to the third over 1, which is just 8. Okay, so that's something that's going to be important with what we are starting today. Right now you should see on your note page, you should see three examples that I want you to complete right now. So pause the video and do the first 3 problems where it says part 1, reviewing exponents. When you're done, come back and I will go over them with you. Okay, I tried to use some of the same numbers and some different numbers just to kind of show you what's going on. So 4 to the third, this is what you should have done. 4 times 4 times 4. That's 64. Then we have 4 to the negative third. So we need to remember that means make this a fraction. So it's 1 over 4 to the third, which is 1 over 4 times 4 times 4, which is 1 over 64. And then the last one, I switched up the numbers, 1 over 6 to the negative second. So the negative exponent means flip it over, and we get 6 squared over 1. And once you flip it over, the negative exponent goes away. And now we have 6 times 6 over 1. But remember, you don't really have to write that over 1. So the answer to this problem is just 36. So that's what you should have on those first 3 problems in your notes. Okay, now we're going to do lots of practice problems. So you will notice on your note page, there will be a place that says practice problems, and you'll see several numbers. So every time I do no problem, I want you to write it down. Some of the times I'll have you pause the video and you'll work it out. Other times I'll go through it first. So let's go. Number 1 is this. 3 to the negative second, 4 squared. Okay? And there may be a dot in between. There may not always be. You just have to know that that is multiplication. All right, so I'm going to go through this one with you. You should already know this one because we did it last week. So I'm no longer going to do 2 separate fractions or, smaller fractions. I'm going to do 1 fraction bar, and I'm going to decide what goes on the top and what goes on the bottom. One of the things that I think you should write on your note page is negative exponents always switch places, and positive exponents stay where they are. Okay, now you have to understand what that means. So, negative exponents switch places. So since I have 3 to the negative second, switch places means right now it's on the top of a fraction because there is an imaginary line with a 1 here. So it's over 1. So 3 to the negative second, we're going to put on the bottom of my new fraction. I'm going to erase this and start over just so you can see it better. So I'm going to put 3 to the second on the bottom. And once it moves, it becomes a positive exponent. 4 squared has a positive exponent. So if you notice, it says positive exponents stay where they're at. So that is what number 1 is really saying. We have 4 squared over 3 squared. You're going to go ahead and multiply it out. And we get 16 over 9. And you always want to check to see if it reduces, which it does not. So your example number 1 is 16 ninths. Okay. Practice problem number 2. All right, so if I have a to the third, b to the negative second. All right, so I'm going to draw my one fraction bar, and we're going to decide what goes on the top and what goes on the bottom. A to the third is going to stay on top because it has a positive exponent, and b to the negative second is going to go to the bottom, because negative exponents switch places, positive exponents stay on top, or stay where they're at, sorry. And my answer is a to the third over b to the second. Okay, problem number 3. We have b to the negative second, c squared, d to the negative third. Okay, pause the video and try and see what you can come up with on this one. When you're ready, start the video again and I'll go over it. All right, so I draw my fraction bar. B to the negative second is going to go to the bottom. C to the second is going to stay on top. D to the negative third is going to go to the bottom. And we get c squared over b squared d to the third. And that's your final answer. Okay, problem number 4. 10x to the negative third, y to the second. Okay, again, pause the video and try it. All right, now coefficients don't follow the whole switch places if they're negative. They are just normal numbers. So that 10 right now is technically on the top of the fraction, and it's going to stay right where it's at. X to the negative third is going to go to the bottom. And y to the second is going to stay where it's at because it's a positive exponent. So my answer is 10y squared over x cubed. Problem number 5. Negative 3x to the negative second, y to the negative second. Okay, pause the video, try simplifying it. Okay, we're going to draw our fraction bar. Now again, remember, this coefficient does not follow exponent rules. So it doesn't move, it doesn't go anywhere, it's just going to stay where it's at on top, negative 3. X to the negative second goes to the bottom. Y to the negative second goes to the bottom. And again, when I move it, the exponent becomes positive. Nothing I can do to that answer, that's my final answer. Problem number 6. We have q to the third times q to the negative fourth. Okay, now we're talking the same variable. So now we're going to know that there's going to be some simplifying that's involved. But we're going to start out the exact same way. So my positive q to the third is going to stay on top. My q to the negative fourth is going to go to the bottom. Now notice what I have. I have q to the third over q to the fourth. Well, since I have q's, I can cancel stuff out. So if you visualize what this problem really is, this is q, q, q over q, 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 q. So what can we simplify? Well, we can go a q for a q. And what I have left is I have 1q on the bottom, and I have nothing on top, so that's just a 1. Now, that's one way you can do it. The other way you can do it is you can look and see, look back here at q to the third and q to the fourth. If I said this were a game and I said q to the third is playing q to the fourth and the highest number wins, well, which one wins? Well, q to the fourth by 1. So I'm going to put my extra q to the first on the bottom, and then the top, they all canceled out. So it's 1 over q to the first. I'll go through that some more on the next problems as we get there. Problem number 7. Okay, what if I had b to the third over b to the sixth? Okay, so one way you can look at this is you can draw a bunch of b's. We have b, 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 lots of b's. And again, we can cancel out a b for a b. So b, 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 b. Okay, I can't cancel anything else out. There's nothing on top, so that's a 1. On the bottom, we have b to the third. That's one way to look at it. The other way to look at it is, again, if b to the third and b to the sixth, they're playing a game, b to the sixth beats b to the third by 3. So he wins by 3. His other 3 cancel out the top 3, and I get 1 over b to the third. Hopefully that's making a little bit more sense. Okay, number 8. All right, now, what happens if we have something like this? B to the negative second over B to the negative third. Well, the first thing we have to do is we have to move things that have negative exponents. And remember I said, negative exponent means flip where it's at. So, the first thing we have to do is we have to say to ourselves, okay, B to the negative second, that's got to flip and go to the bottom. And B to the negative third has to flip and go to the top. Because when you flip it over and you put it in the opposite place, that's what makes the exponent positive. Okay, so now I have b to the third over b to the second. Which b wins by how many? The top b by 1. And what happens on the bottom? I just have a 1 because all those b squareds are gone. And my answer is just b. Okay, I'm going to have you try one by yourself. Number m to the negative second, p to the third, over m to the negative fourth, p to the fifth. All right, pause the video and try it by yourself. Try to simplify it. Okay, so let's think about what we have here. The m to the negative second has to go to the bottom, so it becomes a positive exponent. P to the third has a positive exponent, so it's going to stay where it's at. M to the negative fourth is going to move to the top because it was negative. It's got to go to the top to become positive. And P to the fifth was positive. It stays where it's at. So the beginning problem has to go down to what we just changed it to. And notice I now have all positive exponents. Okay, so now we're ready to simplify. All right, if you look at m to the fourth over m squared, which m wins by how many? Well, the top m wins by 2. If you look at the p's, p to the third over p to the fifth, which p wins by how many? The bottom p, 5 is 2 greater than 3, so the bottom p wins by 2. And this is my final answer. Number 10. Problem number 10, x to the negative third, y to the negative second, over x to the negative sixth, y to the positive 4. Okay, pause the video and try that one. All right, so first of all, We got to move our variables to get rid of the negative exponents. So x to the negative third goes to the bottom, becomes positive. Y to the negative second goes to the bottom and becomes positive. X to the negative sixth has to go to the top, becomes positive. Now, be very careful right here. Y to the fourth, it is not going to move because it has a positive exponent. So it is still in the denominator, and it's okay to have two y's in the denominator. All right, so now we're ready to simplify. So if I have x to the sixth over x to the third, all right, the top x wins by 3. Now, the y's, I can't cancel them out because they're on the same level, so you have to say to yourself, how many y's do I have? Well, if I have 2 and 4 of them, that's 2 plus 4 is 6, so my answer is y to the sixth. So my final answer is x to the third over y to the sixth. Okay, I know that's pretty brand new, so let's try another one of those. Number 11, x to the negative fourth, y to the negative second, z to the sixth, over x to the negative seventh, y to the negative second, z to the negative second. Okay, pause the video and try it. All right, so first of all, we've got to switch things that need to be switched. So x to the negative fourth, it's a negative exponent, it goes to the bottom. Y to the negative second, it goes to the bottom so that we have a positive exponent. Z to the sixth already has a positive exponent, so I'm going to leave it on top where it is. Now go to the bottom. X to the negative seventh has to go to the top, so it's positive. Y to the negative second on the bottom has to go to the top, so it's positive. Z to the negative second has to go to the top because it was negative and needs to become positive. Now, right now, it kind of looks like you have a mess. So you just kind of have to, make sure you understand what is what and what is alike. All right, so let's look at my x's first. I have x to the seventh over x to the fourth. Okay, well, that means 7 minus 4 is 3. The top x wins by 3. Okay, now let's look at the y's. We'll look at the y's. You have y squared and y squared. They cancel each other out, so we have no y's whatsoever. And then the next one we need to look at is we have z to the sixth and z to the second, and they're all on top, which means when I combine them, I have z to the eighth. And I have nothing on the bottom, so there's an imaginary 1. So the answer to this problem is x to the third, z to the 8. All done. Okay, now we're going to put some coefficients in here. All right, number 12. Problem 12 says negative 4, x to the negative second, y, over 10, x to the negative third, y to the negative fourth. Probably shouldn't pause the video. Let's do this one together. All right, so the first thing we need to do is we're going to focus on just our coefficients. Coefficients do not follow exponent rules. All that is that's the fraction, negative 4/10. Well, if I said to you, what does negative 4/10 reduce to? That's just negative 2/5. So this is negative 2 over 5. Okay, now we're ready to move our exponents. So x to the negative second has to go to the bottom and becomes positive. The y has an imaginary 1 on it, and it's a positive, so that's going to stay on top. On the bottom, I have x to the negative third. That's got to go to the top and become positive. Y to the negative fourth needs to go to the top, so it is a positive exponent. Okay, we're ready to start putting together and simplifying. So my negative 2/5, there's nothing I can do to it. That's it. Now, if I look at my x's, I have x squared on the bottom and I have x to the third on the top. The top x wins by 1. So I'm just going to leave an x. I don't have to put the 1. Now, if you look at all your y's, I have y to the first, y to the fourth. They're all on top, so I add them together and I get y to the fifth. So my final answer is negative 2x y to the fifth over 5. Okay, number 13, I'm going to have you try it by yourself. Negative 3 x to the second, y to the negative second, z to the third, over negative 12, x to the negative third, y to the negative second, z to the sixth. Okay, pause the video and try simplifying it by yourself. All right, so here we go. Negative 3 over negative 12. Well, first of all, those two negatives make a positive. 3/12 is just the fraction 1/4, so I'm going to write down 1/4. Okay, I'm ready to remove my x's and my y's and all that fun stuff. X squared is going to stay on top. Y to the negative second from the top goes to the bottom. Z to the third, positive exponent, it's going to stay where it's at. On the bottom, I have x to the negative third, so that's got to go to the top. I'm going to put it right by the other x. Y to the negative second on the bottom's got to go to the top and become positive. And z to the sixth was positive, so it's going to stay where it began. All right, so here's what we have so far. Okay, we've got 1/4. All right, so let's look at those x's. I have x to the second and x to the third on top, and they don't cancel out, so there's 5 of them, so x to the fifth on top. My y's to the second, they're both the same, so they cancel, no y's. And then we have z to the third over z to the sixth. Well, the bottom z wins by 3, so it's z to the third on the bottom. Now, you can write your answer like that, or you can just write x to the fifth over 4z to the third. You don't have to write that 1 if you don't want to. Either one of those answers I would be completely happy with. All right, we got one more problem to do. Okay, so what if I gave you this problem? What if I said negative 7, x to the negative second, y to the third, times 2, x to the negative fifth, y to the negative fourth. Okay, so this is pretty similar to the last problem, except for they're in parentheses and they're multiplying. But you don't even have to worry about multiplying yet. So the first thing we're going to do is we are going to look at the coefficients. And we're going to look at negative 7 times 2. That is multiplication, so we're going to say that's negative 14. Now, I'm going to draw a big fraction bar because I'm going to put stuff where it belongs. X to the negative second, that should go on the bottom of the fraction. Y to the third, it's positive exponent, that should be on the top of the fraction. X to the negative fifth, that should go to the bottom of the fraction. Y to the negative fourth should go to the bottom of the fraction. So all I did first of all was I multiplied my coefficients and then I put my x's and y's wherever they were according to my sign of my exponent. But now I'm ready to simplify. Okay, so I have on top, or let's look at our x's first. All my x's are on the bottom, so I add them together, that's x to the 7th. The negative 14 is just going to stay where it's at. Coefficients don't follow the exponent rules. And then I have y to the third over y to the fourth. So the bottom y wins by 1. So my answer is negative 14 over x to the 7th y. Okay, what you need to do now is you need to go see the substitute teacher and they're going to give you your homework that you need to do for tomorrow. And remember, you can always watch this video again if you need it as you're doing your homework. Have a good day, and I'll see you tomorrow. Okay, now we're going to go on to